Okay, let's see if we can solve this little problem. We're going to try to find the shear moment equations for this beam. It's got a distributed force here and a couple at the end. You are skilled enough now to be able to write your own equilibrium equations, so we can solve those reactions at AY and BY are equal to those values. All right, what I want to do is write an equation for something that happens between A and B. So let's draw a little free body diagram of that section. It's got distributed force. It's got AY, positive shear, and positive moment. Distance x here is where we're trying to get these things as a function of x. Inside that distributed force, or in the middle of that distributed force, we have a resultant. And with distributed forces, we know that the resultant is equal to BH, and x is the base, and h is 50, so that would be equal to 50x. And it acts at a distance of x over 2. All right, how do I get some shear equations? Sum of the forces in the y is equal to 0, so I have 490, which is AY, minus resultant here times, minus the resultant is 50x, minus the shear, and I get this as the shear equation. The moment equation, I'm going to sum the moments about point A. I got minus the resultant times x over 2, minus the shear times distance x, plus the moment, or minus the shear times distance x, plus moment is going to be equal to 0. So plugging shear into, actually it looks like I made a slight error here. Let me correct that. This should be a plus right there, not a negative. Okay, setting this equal to the moment, taking these two onto the other side of the equation. Resultant is equal to 50x. That would be 50x times x over 2, plus shear, which is 490 minus 50x times x. And then you simplify that and you get that equation for the moment. Okay, how about between B and C? Let's go ahead and draw another section and draw a free body diagram of that. I'll move that up just a little bit here while I draw the free body diagram. Oops. All right, here's the free body diagram. I have AY. This is my little section there. I have a distributed force here, and it is resultant, which is equal to 50 times 20, which is equal to 1,000, and it acts at a distance of 10. I have BY, then I have positive shear, positive moment. My whole distance is x this way. All right, now that I have that, sum of the forces in the y is equal to 0. Sum of the forces in the y. Maybe you can walk through my specifics here, but this is 490. This is 1,000 going down. BY is going up. Shear is equal to, shear is equal to 0. It is not a function of x because all of these forces are known and evaluated. How about the moment? The moment, some of the moments about A, I got 1,000 times 10 plus 510 times 20 minus shear, which is 0, plus the moment is equal to 0, and so moment is equal to negative 200. We can graph that equation, or both of these equations, and see what we get. So let's look at the shear graph. It says it starts at 490. It looks like it is it has a negative slope of 50x. And so if I look at what it is at x is equal to 20, let's go down here. Where I want to do is evaluate this at x is equal to 20, right there. And then I can find out what it is there. At x is equal to 20, it is negative 510. So I'm going to draw this kind of back here, negative 510. This is an equation of a straight line, so I know that this goes straight down. Then what it says is that the shear is equal to 0 after that, so it means it goes straight up and meets the graph and stays at 0. There's our shear equation. How about the moment equation, or the moment set of equations? Let's move this up just a little bit. All right, the moment starts at 0 between A and B, and it at x is equal to 20, it goes up. It looks like it's a quadratic. It goes up, and then where x is equal to 20, it has a value of negative 200. So I'm just going to draw it in here, and you can, for your own benefit, you can see what it does. It looks like something like that. And then what it says, between B and C, it stays at negative 200 until it gets to the end of the beam. What we'll find is that where the shear crosses 0, the moment is the maximum. Sometimes our desire is to find that. In fact, most of the time our desire is to find that. We do that by saying, where is shear equal to 0 here, and finding that x value. Plugging 0 in for shear, which is right here, find that x value. We find that that is equal to 9.8. At 9.8, I plug that into the moment equation, which is right here, and I can find out the maximum moment is equal to 2401. Okay, well, that's just a little bit of an introduction here on how to do the shear and moment diagrams and coming from the equations.